This is exercise 21 in chapter 7 of our textbook, where it says a certain population has a mean of 500 and a standard deviation of 30. So we know a population mean is denoted with the variable mu, so mu is 500, and a population standard deviation is denoted with the variable sigma. So sigma is equal to 30. Many samples of size 36 are randomly selected and the means are calculated. So we're taking repeated samples of size 36, and every time a sample is taken, we are plotting the mean, and we continue to do so over and over and over again. In A, what value would you expect to find for the mean of all of these sample means? Well, we know that what's being created is what's known as the sampling distribution for sample means. And we have learned that the sampling distribution for sample means will be centered at the true population mean. So they're asking for all the mean of all the sample means, and that should be equal to 500 in this case. In B, we're asked what value would you expect to find the standard deviation of all of these sample means? And we know that this is where they're asking us for the standard deviation of the x bars. And we've learned again that that is found by taking standard deviation of the population and dividing by the square root of n. So our population standard deviation is 30. When we divide that by the square root of 36, we get the standard deviation of our sampling distribution, also known as the standard error, equal to 5. And then finally in C, what shape would you expect this distribution of all these sample means to have? Well, according to the central limit theorem, regardless of the shape of the population distribution, when n is large, and that means greater than or equal to 30, the sampling distribution will be approximately normal. In this case, our sample is greater than 30, therefore the distribution of our sample means will be approximately normal.